Hello friends, welcome to our channel. Today also continue another lecture. Today I will discuss that is a two address instruction. I have already discussed in three address instruction in last lectures. So today I will discuss regarding on two address instruction. So if we go through two address instruction, same thing we will go through, that is a two variable or two operands. That means the instruction defined through two operands. Okay, and each instruction defined through two operands. Based on that we can define that is a two address instruction. Same concept, let us consider that is one expression x is equal to a plus b into c plus d. Okay, this expression we have to design. So two address instruction are most common in commercial computers. Most of the time that is it they use two address instructions. Okay, again its instruction field can specify either process register or memory. Okay, that is since it is a two address register, so one part is register, another part is that is memory, because if we go through previous three address register, then we use that is only registers. Okay, and for memory also register and memory, but similarly here is a register and memory, one register and one memory. Okay, so how it is defined or how it is used or how we will express through instruction using one memory and one address, one register. Here what happens, very simple way we just use that operation like this, move r1 a. Okay, since two operand is required, one is a register, another is a memory, so a data transfer to r1. Okay, a data transfer to r1. In that case what happens, r1, okay, r1 keeps the data of a, because since just move a data content of a transfer to r1 or move content of a to r1. So in this way we can define. So r1 now contain r1, r1 contains memory data a. Okay, next here is one part is there ra, or a is defined, again is b is defined with the addition. In that case one trick just apply, that is add of what, b with the r1, because r1 contain a. Okay, here what happens, very simple way we can define r1 and b. Okay, r1 already contain ma. Okay, and when add with b, then we can define in this way. So we can write that is r1, here r1 plus mb. Okay, r1 plus mb, because r1 here r1 contains this data, r1 contains this data already is there, because r1 already defined, this data already defined. So r1, this r1 means ma. Okay, r1 means ma plus mb, and whole data stored in r1. So r1 is updated in this way. Okay, so next this is for this is a b, one part is over. Similarly second part similarly second part, how to define, same case, right, move, here r1 contains both, here r2 we can write r2, how, c, because r2 another part is c and c plus d, here also r2 contain mc. Okay, r2 contain mc, and similarly add of same case r2, that is d. Then what happens, r2 contain r1 plus md. Okay, r1 plus md. Now what happens, r2, here r2 plus md. So this r2 contains mc plus md. Okay, r2 contains mc plus md. Now r1 and r2 both are, here you see both are contain a plus b and c plus d. Okay, now see again we just multiply, r1 r2 already there, so there is no problem. So here is R1 and R2. Okay. In this case, what happens? R1 already defined, R2 already defined. Then what happens? R1 store the R1 multiply with the R2. Okay. R1 store the R1 with the multiply. That total data store in R1 and only R1 content this one. Again what happens? But our aim is that data store in X. So move here X R1. Okay. In that case, what happens? How to define? Here R1 content of R1 transfer to X. So we can write X means memory X transfer, that is R1 content transfer to X. That means R1 is what? R1 into R2. Both multiplication transfer to, that is MX. Okay. You see, that means content of R1 transfer to MX, memory X. You see, here what happens? Each instruction having two address. You see, 1 2 1 2 1 2 1 2 1 2. Each address or each instruction having two address. For the reason we can tell as a two address instruction. Very simple here. First, what happens? Just move A data to R1, add B data to R1, already R1 content this one. So R1 receive the data R1 plus MB. Very simple we can write. Similarly, C plus D. C move C data to R2, again it add with the D data. Okay. So in that case what happens? R2 plus MD. In this way both are adding and store in R2. Once R1 and R2 find out its corresponding addition of two data, then now we will multiply that data with that data, means R1 and R2, and store in R1. Once we got this final data in R1, then transfer to X by memory of X. Very simple way we can transfer, doesn't matter. We transfer this way R1 to memory X. Whenever you write X, A, B, C, be careful, you don't leave. You have to write that is memory of X or memory of A, memory of B or C. If any register used, no need to write memory. If you write A, B, C, D, X, Y, Z, P, Q, R, whatever that data, we write or use memory, because memory used for that. Register point of view, M is not required. This symbol is not required for register. If you go through X, A, B, C, D, use that memory. Okay, M of that particular content of data. Okay, in this way we can define. So now I hope all of you understand this two address instruction, how it is defined of a given expression. This expression is given, how it is defined. This is very simple way I explained. I hope all of you understand this particular two address instruction. Okay, thank you, thanks to all. Please subscribe my channel and comment on this particular comments to my videos. If you like, then you can like it. Okay, thanks to all.